What's going on, everyone? So Dirtcuz invited me and actually challenged me to take a look at his video, his long distance observation here, and see if I could debunk it. He filmed from the Big Island of Hawaii, saying there's no curvature across 84 miles. So let's break this down carefully because it's a really good long distance observation. Now, he filmed this in landscape and I'm doing this vertically. So I'm going to crop some of his video and I'll show you when I crop it so you know I'm not taking stuff out of context. So he goes through his application for the long distance world record photo. And then he gives us more information than pretty much any flat earther does. And he gives us a location. Now, it's not exactly typed out with the GPS coordinates, but we can see pretty close to where it's at and make a good guess. So we're going to look at it on Google Maps. It looks like he is over here. And then there's the white road. This little road is on his view. But it looks like he puts a pin drop on the road and it looks like he comes out to about right here. But it looks like he's here at these coordinates. He explains a few things and then he scans across the horizon and shows these islands. And I think this is real color, possibly. He did put a filter on and it made the islands a lot more visible because of the contrast. So we're going to use that. But he scans across Kahoʻolawe, and then this point here is the important one, where he crosses between Kahoʻolawe and Lanai. So let's check out those measurements. Now we know he's over here. What we're going to do is look at Lanai first. I don't know if that's how it's pronounced. We're going to assume yes. We're going to find the highest peak, which is right there. If I can get this to move, there we go. And then we'll just draw a line straight to where he was at. So this is the longest confirmed observation he has. And you can see there I was drawing because I was trying to get his elevation. So it looks like 79.67 miles. So yeah, 79.9 miles is what's showing up here. Let's plug that into the Walter Bislin's Advanced Earth Curve Calculator. So the observer height, he said 210. It looked like I got around 200. So we'll just use 200. Target distance, 80 miles. And then the target size. So the peak, the tallest peak is 3,370 feet. That's this peak here. So it looks like with zero refraction, we are missing 2,600. We can see 750 feet. With standard refraction, we're missing 2,000 feet. We're seeing 1,300 feet. So let's look at that on PeakFinder and compare. So this is PeakFinder. We got the coordinates for where he's at. From our Google Maps. You can see that put him at 203 feet, the little pin drop that we did. But this matches his observation. He's scrolling sideways. We're seeing this mountain or this island. And then we see that crossover that happens and we see Lanai. And then he pans across and we see a ton of water. And then we see Maui, the island of Maui. Now, here is something that I kind of find interesting with this. So we're going to start over here. We can click this and it'll tell us the distance and what the elevation is. So you can kind of see here, we move it around. We get 0 feet elevation, 0 feet elevation, because this is going off of the water. But then once we crest this here, so we're at 15, 16, it jumps up. So 16 and then pow, 53 miles, 74 feet of elevation right there. So it looks like it's missing 763 feet essentially behind the horizon line there. We can do that here we'll do that with Lanai. So we're going up, right? We got 14, 16, jumps to 78 miles, 2,067 feet is where that elevation is. And that matches really close to what Walter Bislin says. And then we drop it back down and bam, 0 feet, 14 miles. It goes up to 16. I just it's hard because you got to move it super fine. And that's the most I can zoom in. And then we can do it over here too. So I'm going to do it with the edge as close to this as I can get where it's touching the water, because we're going to see something. So 47 miles, 467 feet. So it is interesting that it looks like the farther we go out, the more land seems to disappear behind the horizon. And I'm just going to plug in 47 miles here. 433 feet missing, 460 feet elevation. So pretty close. It looks like, yeah, the closer the island, the less that is hidden behind this solid horizon line that we're seeing. Now let's talk about this other island, Molokai. That's probably butchered. There is a massive mountain right there that if we look, it's sitting at almost 5,000 feet above sea level. When Dirt Cousin pans, we don't see this peak. And my guess is because shorter parts of Maui are blocking it. So we're gonna draw a line. So it is 92 miles. And this is the elevation profile of it. So you can see that part of land is shorter there. That part of land is shorter to that peak. So realistically, from his view, we should be able to see that peak barely, but we don't. If Earth was flat, I feel like we should be able to see it over this. Now, this is something else that I find interesting. So I drew these two lines here that are basically his view between those islands. So we're kind of touching a little bit of island here, but we're not touching a bunch of island there. This was kind of by eye while I was zoomed out. And let's see. When we look at Dirt's video, he's scanning sideways and we're just seeing a horizon of solid water. But this has like 12 miles essentially of land that we aren't seeing. And we can see that it does have some elevation at least. So if we were seeing this, it shouldn't be a straight line when he's panning across. We should see this. Now there are two ways to verify, because when Lanai is behind here, it's kind of hard to tell. Lanai has a pretty basic shape to it, but one thing that we can check is Maui. The line, we can check the elevation profile of Maui. So when we see Maui, he's like scanning sideways, and we have this nice little flat spot, and then it shoots up again, dips down, and then slowly up. So something that we can do is use PeakFinder and line that up. So it looks like it matches this profile pretty well. So we'll actually this will work kind of perfect, because that's not too far for what we're seeing. So we'll look at where Kahoʻolawe is. I probably butcher it. Okay, so it's right there. Actually, I'm going to assume this is slightly off, and it's probably this thing, because that's an actual, like, unique feature as opposed to just random jungle. And then what I think we're seeing is flat here, up, and then it does that little down and then back up again. But it is kind of hard to tell. So it is kind of hard to side by side the video when he hits Maui, but we can kind of line it up a little bit. You can be the judge of that. So this is something that I just found kind of fun. I grabbed the GIS data of Lanai, and this is the height in meters, 1026. And I don't know how to scroll sideways because I'm not a Blender person. But what's cool is we can then take this 620 meters hidden, plug it in, and see that we should still see the top of this. Like I said, Lanai is kind of hard because it looks very basic, but But yeah, this works fine with the globe. It's really hard to tell with how not defined anything looks on Lanai from Dirt's video. But the observation does work on a globe. For what we do see, we don't see pretty much any of Molokai. The tallest part's hidden behind part of the Maui. Someone else, if you want, you could try to compare the side-by-side of this sloping mountain in his video. It looks kind of close, that like we see this slight uptick and then this little flatten out area and then it climbs again. But again, kind of hard to completely tell. But in the end, Dirt Cousin's challenge turned into a pretty good observation that matches the globe Earth as far as I can tell. It looks like Lanai's base is gone. Maui's lower slopes are missing. We aren't seeing pretty much any of Molokai between Maui and Lanai. And the horizon on PeakFinder sits pretty consistent and then jumps up once we get, see, that's 45, that's 47. So we could judge it closer and judge like over here. So without the super defined lines on anything, it's hard to tell, but I'm going to take this as a pretty good close to globe Earth match. Now, again, like I said, this is what Lanai shows us on PeakFinder. We look at it on the Blender model that I can't seem to figure out how to use correctly. Same thing. We just have like not a very defined mountain. Not a very uniquely defined mountain. But yeah, I wasn't going to dig into this at all. Dirt Cousin kind of threw that invite out, and I'm always open for a challenge. I learned a lot about the Hawaiian Islands doing this, so that was kind of cool, about like the topography and the elevations and the mountain peaks and how tall they shoot out of the Pacific Ocean. Yeah, test everything yourself. There are tools in today's day and age that we can use. I suck at Blender. I have no idea what I'm doing. ChatGPT walked me through how to even make a square that I could change the size of.